In the previous lecture, we have gone through some amplifier circuits using operational amplifier. Okay, inverting amplifier, non-inverting amplifier, and various kinds of circuits. Now let us have a look at the next application, adders, adder, subtractor. In this section, I will be discussing these things: adder, subtractor, etc. Differential amplifier. Now, adder or summing amplifier. How does the circuit appear? The very first basic circuit using inverting configuration is like this. Two inputs are given, V1, V2, and R1, R2 are the two resistors from inputs, and RF is the feedback resistor. Okay. So, how to find the output in this particular case? See, due to virtual short, it is 0 volts. Then let me take this node equation. KCL at node A. If I take this as node A, then zero minus V1 by R1 plus 0 minus V2 by R2 plus 0 minus V output by RF is equal to 0. Then V output by RF is equal to minus V1 by R1 minus V2 by R2, or I can write V output is equal to minus RF by R1 into V1 minus RF by R2 into V2. Means here both V1 and V2 are amplified, but V1 is amplified by an amount RF by R1 and V2 is amplified by an amount RF by R2. Negative sign comes because we are giving input to the inverting terminal. Or even we can write it like this: minus sign common, RF by R1 into V1 plus RF by R2 into V2, known as summing amplifier. So the amplified outputs are added. Okay, this is one way we can write it. There is an alternative method, that is superposition. You can even use the superposition method, you will get the same result. But okay, not required. We can take that as otherwise. Okay, as it is the first example, let me do it, not an issue. I'm just taking the same circuit, superposition. So while studying the effect of one source, let me take the other source 0. So here V2 is set to be 0. It is R2, RF, R1 and V1. So due to virtual short, it is 0 volts. So here it is 0 and here also it is 0. Let me take the corresponding output as V1. Okay, sorry. So what happens? There is no role of this R2. I can simply remove this R2. It does not play any. No current is possible through this. So it is same as that of our basic circuit only. So what is the output? Minus RF by R1 into V1. Similarly, for studying the effect of V2, set V1 is equal to 0. Second case I am writing. V2 R2 V output RF R1. It is again connected to ground. Due to virtual short, it is 0 volts. So here it is 0 and here also it is 0 as V1 is 0. So again, now if you observe this, there is no role of this R1. I can simply remove this. Or if I take the node equation here, what we can see? Okay, it is minus Rf by R2 into V2. Let me take it as VO2. So overall response is sum of the individual responses. So first case what we do, by setting V2, what is the response of the system due to V1, input V1. And if V1 is set 0, then what is the response of the system due to the input V2. So overall response is VO1 plus VO2, that is minus Rf by R1 into V1 minus Rf by R2 into V2. Like this we can write it. Okay, we can think of the superposition for two inputs. More than two inputs not is right, it will kill the time. Okay, but maximum ourselves blindly you can see with nodal analysis. Apply virtual shop, take the node equation. Okay, so like this. Instead of two inputs, you have multiple inputs, maybe 3 or 4, 5. The procedure remains the same. So for multiple inputs, okay, V1, V2, so on Vn, n number of inputs, R1, R2, so on Rn. And this is our feedback resistor R. Then what is the output? So V output is equal to, I'm directly writing it, minus Rf by R1 into V1 minus Rf by R2 into V2, so on, minus Rf by R1, sorry, Rn into Vn. Like this we can write. Suppose all the resistors are equal. Then what is the output? It is equal to minus R by R into V1 minus R by R into V2, so on, minus R by R into Vn is equal to minus of V1 plus V2 plus so on plus Vn, known as simple adder circuit. Okay, it is a summing amplifier. I can say it is known as I mentioned, of course, known as summing amplifier. Here it is known as adder. Simply we are adding all the signals, known as adder. That's it. Of course, the condition we know, output should not exceed plus or minus V saturation. It should not reach those values. Otherwise, no issues. Okay, like this we can take. I am not writing the circuit with all equal resistors. How it appears, you know. Okay, it may be 2 inputs or 3 inputs or n inputs. Doesn't matter. Okay, next with non-inverting. Okay, just this is one simple question asked in previous papers. So all the resistors are equal here. So what is output? Minus of V1 plus V2. If it is n inputs, then we can write. Right, so 2 inputs. So what do we get here? It is minus of 1 plus 2 minus 3 volts. It's as simple as that. Resistors are equal here. Okay, here instead of resistors, they gave capacitors. For that, they mentioned the frequency of the two inputs. Okay, see, instead of resistors, you have impedances. What we write? I have some impedance here, Z1, and one more impedance, Z2, and it is the feedback resistor ZF. V1, V2, V output. Instead of resistors, I have impedances. So it is minus ZF by Z1 into V1 minus ZF by Z2 into V2. The thing here is V1 and V2 should be sinusoidal signal, or I can write V1 of t and V2 of t. right? If we want, we can write it like that also. V1 and V2 should have same frequency or time period. That's the must and should condition. Okay, where V1 of t and V2 of t should have same frequency. That's very, very important. Okay, so here the capacitors are given. So it is like ZF is equal to 1 by j omega c, and Z1 is equal to 1 by j omega c, and Z2 is also equal to 1 by j omega c. Impedances, you can't write only C1 by C2 or j omega c. One way, impedance of a capacitor we are well aware, 1 by j omega. Then Z1, Z2, ZF are equal. In that case, what is your output? Absolutely minus of V1 plus V2. Is it not so? Right. So, in this example, what is our output? It is equal to actually minus ZF by Z1 into V1 of t minus ZF by Z2 into V2 of t. Anyway, ZF, Z1, Z2 are same. So, minus of V1 of t minus V2 of t. What is V1 of t? It is V1 sin omega t minus V2 sin omega t. It is minus of V1 plus V2 sin omega t. That's it. Like this we can write. It's a very, very simple thing. Okay, and suppose the capacitors are like, okay, they are not equal. Then Z1, Z of Z2 will not be equal. All right, I will write it in the next page. Okay, so here I will write. CF C1 C2. Then what is V output? Okay, ZF by Z1, that is 1 by j omega CF by 1 by j omega C1 into V1 minus 1 by j omega CF by 1 by j omega C2 into V2. 1 by j omega, 1 by j omega cancel. It is minus C1 by CF into V1 minus C2 by CF into V2. It's a general thing. And you can have inductors also, doesn't matter. So if you have reactive terms, what do we do? The condition is both V1 and V2 should have the same frequency. Then only we can write Z1, Z2, ZF properly. Otherwise, okay. Like this, we can do this. So what is the correct answer? C. Okay. And non-inverting adder circuit. Okay, instead of giving input to the inverting terminal, we are giving input to the non-inverting terminal. Okay, so how do we do this? Let us take this voltage V plus. How to find the voltage V plus? You can take the node equation here. Okay, let me take KCL at node A. Let me take it as node A. It is V plus minus V1 by R plus V plus minus V2 by R is equal to 0. So what is V plus? It is, anyway, R and R cancel. So implies V plus is equal to V1 plus V2 by 2, that is equal to V minus due to virtual short. Okay, and once I know the voltage here or here, what is the output here? Output V output is equal to 1 plus R by R into V minus or V minus or V plus, right? Basic non-inverting amplifier output we know. So it is 2 into V1 plus V2 by 2 cancel, and it is V1 plus V2. A simple adder circuit. Adder I mentioned. If the resistors are not equal, then I can say an amplifier. Okay, summing amplifier I can say. As the resistors are equal, I am getting V output is equal to V1 plus V2, which is known as a simple adder circuit. Okay, for 2 inputs I can write like this. For 3 inputs, 4 inputs, do we follow the similar way? No, absolutely not. That is true for only inverting configuration. Okay, for inverting configuration, just like that we can write it. But if all the resistors are equal, then output is equal to minus of V1 plus V2 plus so on. Like that we can write. But whereas for non-inverting configuration, for 3 inputs, how the things? It is not R, it should be 2R. This resistor value changes. See, let me take V plus here. Voltage at the non-inverting terminal. What can we write? Node A, KCL at node A. V plus minus V1 by R plus V plus minus V2 by R plus V plus minus V3 by R is equal to 0. Anyway, we can cancel this R. So, V plus is equal to V1 plus V2 plus V3 by 3. Okay. Perfect adder circuit I am looking at. Once I know this voltage V plus is equal to V minus. So, V output is equal to 1 plus 2 R by R into voltage at this point or voltage at this point. V minus. It is 3 into V1 plus V2 plus V3 by 3. 3 and 3 cancel. It is V1 plus V2 plus V3. That's it. So, this resistor value is changed. Is it not? And 4 inputs, just as an extension I am mentioning here. 4 inputs means instead of R, it should be 3R. Okay. Here look at the sum of the resistors R plus R plus R plus R, 4R, and this R plus 3R. The total should be 4R. Okay. The procedure remains the same. It is V plus node A and V minus is equal to V plus. Absolutely, we can write it. So KCL at node A, it is V plus minus V1 by R plus V plus minus V2 by R plus V plus minus V3 by R plus V plus minus V4 by R is equal to 0. So, what is V plus? It is V1 plus V2 plus V3 plus V4 by 4. Then what about V output? You understand now 3R by R into V minus. Of course, this is equal to V minus due to virtual short. So it is R cancel. It is 4 into V1 plus V2 plus V3 plus V4 by 4. 4 and 4 cancel. V1 plus V2 plus V3 plus V4 like this. Okay. You may have n number of inputs based on if the number of inputs are n, and here this resistor should be n minus 1 into R. That's it. Next. See this question. A non-inverting op-amp amplifier is shown in figure. The output voltage is a very simple thing. So 2 inputs, but here instead of R they gave 2R. 2 inputs means n is 2. So n minus 1 into R if you have, then I can write V1 plus V2 blindly. But it is not so. It is 2R. So anyway, what is the voltage at this point? It is V plus. So if we take the node equation, right, I can take the node equation or superposition, anything I can apply. So KCL at node A, it is V plus minus of minus plus 2 by R plus V plus minus of 2 plus sine 100t by R is equal to 0. Anyway, R and R cancel. So V plus is equal to sine 100t. Okay, 2 and minus 2 cancel. Anyway, we get this one. by 2, sorry. So 2V plus is equal to. Then once you get it, that is of course equal to V minus. So what is V output? It is 1 plus 2R by R into V minus. It is 3 by 2 sine 100. 3 by 2 means 1.5. So option A is correct. Very, very simple. Okay. Right. So given figure shows a non-inverting op-amp somewhere with V1 is equal to 2 and V2 is equal to minus 1 volt. The output is, what is the output of this circuit? Okay. So it is V plus V minus node A. KCL at node A. It is V plus minus 2 by R plus V plus minus of minus plus 1 by R plus V plus minus 0 by R is equal to 0. These three R's will be cancelled. So V plus is equal to 1 or 3V plus is equal to 1 or V plus is equal to 1 by 3 volts, that is of course equal to V minus. Okay. Once you get V plus, then what is V output? It is equal to 1 plus 2R by R into V minus. So it is 3 into 1 by 3. 1 volt is the answer. So very simple. See, the op amps is very, very easy, but topics are more. Just we see n number of circuits, but the procedure remains the same. Okay, next one, op amp differential amplifier, which amplifies the difference of two inputs. Differential amplifier will say. So far we have seen adder circuits or an amplifier, right? Adding amplifying more than one input. Okay, 2 inputs, 3 inputs, and inputs. You can give input to the inverting or non-inverting terminals. Next one is amplifying the difference of the two inputs. Okay, from which you can see a subtractor circuit also. See the first circuit, differential amplifier. Actually, it's a very, very interesting topic, differential amplifier. Lot of things based from the differential amplifier, we design the instrumentation amplifier. All right, when that topic comes, we'll see that. And here only we study the concepts of common mode rejection ratio, CMRR and all. Right, we discuss the differential amplifier using BJT, FET, and all those things using op amp, etc. But here, this is a basic level. We will see the actual differential amplifier in the upcoming sessions. Here it's very simple actually. Right. So what I'm doing is, okay, just instead of giving input to only to inverting or non-inverting, I'm applying input to both the terminals. So how do we analyze this one? We can take due to virtual short. Here you can take superposition also. While studying the effect of V1, we can set V2 0. So what is the output? Minus R1 by R2 into, sorry, 1 plus R1 by R2 into V1. While studying the effect of V2, we can set V1 0. What is the output? Minus R1 by R2 into V2. So overall output is VO1 plus VO2. We can write the answer. Okay. That is the basic method we can take. We can apply superposition or we can apply nodal analysis. Okay, just I'm writing with a superposition. Suppose V2 is 0, the corresponding output is VO1, R1, R2. What is the output of this circuit? Once you know V plus, which is equal to V minus, output is 1 plus R1 by R2 into V1. And suppose V1 is equal to 0, then R1, R2, V2. What is the output of this circuit? Minus R1 by R2 into V2. So overall output is equal to VO1 plus VO2. That is 1 plus R1 by R2 into V1 minus R1 by R2 into. It's as simple as that. Or you can use nodal analysis, you get the same result. Okay. That's it. So whenever you have two inputs, once you know the voltage here and here, directly I will be writing this equation. Just mask one input and take the output. And next mask the other input and take the output. For two inputs, it's better to use superposition sometimes. Okay. So nodal analysis anyway, we are well aware how to write the things. Okay. Now here it looks like V1 is amplified by some amount and V2 is amplified by some amount. Both are amplified and you are taking the difference of the amplified signals. Okay. It's not exactly a differential amplifier. It's something like V1 and V2 are amplified and you are taking the difference of the amplified results. Okay. Right. Next, keep this aside. Next circuit I'm taking is this one. Okay, instead of giving V1 directly to the non-inverting terminal, we are giving through the resistors R1 and R3 and R4. Okay, how do we take the output? So first let me take this voltage V plus. What is V plus? Entire current will go like this. So V plus is equal to V1 into R4 by R3 plus R4. Okay, once you know the voltage at the non-inverting terminal, and this voltage, what is the previous circuit only? What is the output, friends? V output is equal to, okay, 1 plus R1 by R2 into V plus, we can write, which is of course equal to V minus, and the effect of V2, that is minus R1 by R2 into V2. Okay, some people may be having a doubt like what happens with this R3 and R4. Why did I write this circuit is not looking similar to the previous case? Okay, right. For that, let me do one thing. Otherwise, I am writing it directly, right? I am removing everything. Okay, superposition only I am taking. While studying the effect of V1, we set V2 0. What is V1? Anyway, V plus, once you calculate V plus, then we can write it. What is V plus? Entire current goes like this. So here V plus is equal to V1 into R4 by R3 plus R4. So what is VO1 then? VO1 is equal to 1 plus R1 by R2 into V plus or V minus 1 plus R1 by R2 into V1 into R4 by R3 plus R4. Like this we can write. And suppose V1 is equal to 0. Then what is the output? Due to V2 minus plus R4 R3 So R3 and R4 are parallel, through which no current is possible. They do not play any role here. Okay, some R equivalent I can write, through which no current is possible. Here, this current is 0. As the current going here is 0, means no current is possible through R3 and R4. I can discard them. So corresponding output is minus R1 by R2 into. So what is my overall output? VO1 plus VO2, that is 1 plus R1 by R2 into R4 by R3 plus R4 into V1 minus R1 by R2 into V2. Okay. We can write the output equation like this. Now, it is also not a differential amplifier. V1 is amplified by some amount and V2 is amplified by some amount. Earlier case, I cannot see that both V1 and V2 are amplified by the same magnitude. No, because here it is 1 plus R1 by R2. Here the gain is right 1 plus R1 by R2. And as far as V2 is concerned, the gain is minus R1 by R2. So I cannot say that both V1 and V2 are amplified by the same factor. Not possible here. But here there is a scope. Right? Both V1 and V2 can be amplified by the same factor. Means the amplification factor of V1 and amplification factor of V2 can be same. Possible. Okay, earlier 1 plus R1 by R2 cannot be equal to R1 by R2. But here R4 by R3 plus R4 is present, hence it is possible. Okay, so V1 and V2 will be amplified by the same factor if and only if. So I am writing here both V1 and V2 will be amplified by same factor if 1 plus R1 by R2 multiplied with R4 by R3 plus R4 is equal to R1 by R2. The gains should be same. Okay, and it is further written like R1 plus R2 by R2 multiplied with R4 by R3 plus R4 is equal to R1 by R2. These two will be cancelled. So now by cross multiplying, I can write R4 into R1 plus R2 is equal to R1 into R3 plus R4. That is R1 R4 plus R2 R4 is equal to R1 R3 plus R1 R4. R1 R4 is cancelled on both sides. So R1 by R2 is equal to R3 by, I can use this condition, doesn't matter, or R1 R3 is equal to R2 R4. We can write this is the condition. If this condition is met, then how much amount V1 is amplified, the same amount V2 also will be amplified. Or I can write R1 by R2 is equal to R4 by R3. Okay, how do we remember this? See, just see from right to left. So R1 by R2 is equal to, again, right, with respect to inverting terminal, right, you are taking R1 by R2. And with respect to non-inverting terminal, what you can write? R4 by R3. So R1 by R2 is equal to R4 by R3. Then the amplification factor of V1 is equal to the amplification factor of V2. This is the condition. Okay, so what I can write from this, so that V output is equal to V1 is amplified by this factor now I mentioned. Instead of this big factor, I can simply write R1 by R2 into V1, and as usual V2 is amplified by the factor R1 by R2 into, or now I can write R1 by R2 into V1 minus V2, or V1 and V2 are amplified by the same factor. Now the output is R1 by R2 into V1 minus V2. So the difference of V1 and V2 is amplified by a factor R1 by R2. Hence the name differential amplifier. Okay, the difference of V1 and V2, which is not possible in the previous case. You can see V1 and V2 are amplified by some factor, but the factors are not equal. But here, if this condition is met, then V1 and V2 will be amplified by the same factor. So known as differential amplifier. So how does the circuit appear? Further modifying the circuit. R1, R2, V2, V1, R2, R1. The best way to write is like this. So that the output is equal to R1 by R2 into V1 minus V2. Voltage input given to the non-inverting terminal minus input given to the inverting terminal. Like this we can. Further, suppose R1 is equal to R2, then what is V output? V1 minus V2 means it is the difference of the two inputs known as subtractor. Okay. Further, I am writing, suppose V1 is equal to, sorry, not V1 is equal to V2, R1 is equal to R2. R is equal to R. Then what about V output? R by R into V1 minus V2, which is V1 minus V2, known as subtractor. How does the subtractor circuit appear? Means minus, plus, I am taking all equal resistors. Here it is V1 and that's it. Okay, we have seen summing amplifiers and adder circuits and differential amplifier and subtractor. Like this we can take. It is known as a subtractor. All the resistors are. See this question. If the op-amp in the figure is ideal, the output voltage V output will be equal to, what is the output of this circuit? Do you see any R1 by R2 is equal to R4 by R3? No. So we can just go with the regular method. So how do we write the output here? V output is equal to, right here, V plus. So what we can write? 1 plus 5k by 1k into V plus minus 5k by 1k into 2. So it is 6 into, what is V plus? Voltage division rule, that is 3 into 8k by 1 kilo ohm plus 8k, that is our V plus minus 10 volts. Okay, so 18 into 8 by 9, 9 2's minus 10, 16 minus 10, it is 6 volts. So option B is correct. Anyway, they mentioned 14, 17, but we do not know the power supplies. They should give the power supplies, VCC minus VCC, maybe around 15 like that. If they give, we can understand from that. Anyway, right, our 6 volts is no issues with respect to the answer. So we can take. In the circuit below, the operational amplifier is ideal. If V1 is equal to 10 millivolts and V2 is equal to 50 millivolts, see they changed. Right? We have a practice of writing V1 at the bottom and V2 at the top. It doesn't matter. Right? Reverse with it. Next, here it is R1, R2, the same R1, R2. So it is a differential amplifier. So what is the output then? R1 by R2 into, in this example, it is V2 minus V1. 100k by 10k into, what is V2? 50 millivolt minus 10 millivolt, 40 millivolt into 10, 400 millivolts. Option C is correct. Okay, 0.4 volts is the answer. In the given circuit, if the voltage inputs V1 and V2 are to be amplified by the same amplification factor, the value of R should be. Yes, V1 and V2 will be amplified by the same factor if and only if this resistor by this resistor is equal to this resistor by this resistor. So the condition we know 22K by 10K is equal to R by 15K. You have to observe from right to left, right, with respect to the inverting input and non-inverting input. You say this is what you can say. R will be in kilo ohms. So anyway, kilo I am cancelling. No, sorry, here I cannot. Right, both. Sorry. So 5 3s to 11s. So R is equal to 33 kilo ohms. That's it. It's a very simple question. Design op-amp circuit with inputs V1 and V2 such that V output is equal to minus 5 times V1 plus 3 V2. Okay. So what we can do, it is possible, such things are possible with the two inputs being given to inverting and non-inverting terminals. Okay. Minus 5 V1. Let me take V1 to the inverting terminal and V2 to non-inverting terminal. How do we choose the resistors? Right, R1, R2. R1 by R2, right, we know V output is equal to minus R1 by R2 into V1. Okay. And with respect to V2, what we write? It is R4, R3. So R4 into V2 by R3 plus R4. Of course, this is multiplied with 1 plus R1 by R2. Okay. So if I choose R1 is equal to 5K and R2 is equal to 1K, it's possible. Suppose R1 is equal to 5K and R2 is equal to 1 kilo ohm. So R1 by R2 is 5. No issues. And what about R3 and R4? Anyway, R1 by R2, it is 5. 5 plus 1, it is 6. But what we want? 3. 3 means R3 is equal to R4 is equal to some 1K. Anything we can take it. So let R3 is equal to R4 is equal to, you can take 1K or 2K or 5K, doesn't matter. Okay, just for difference sake, I'm taking some 2 kilo. Then what is the overall output? You can just check it. Just like that we get the answer. Okay. V output is equal to minus 5K by 1K into V1. 1 plus, okay, plus 1 plus 5K by 1K, it is 6 into 2K by 2K plus 2K into V2. Absolutely 3 V2. Some values I'm taking this way. Okay, you need not worry about taking the same values, just as an example I'm taking. Next. In the circuit given below, the op-amp is ideal, the output in volts. Okay, what is the output of this circuit? So many times without this signal, right, this connection we did. Now that some extra connection is given. So how do we do this? First, let us take V plus. What is V plus? V plus is equal to, so voltage division rule, both are equal, 4 into 10K by 10K plus 10K, it is 2 volts. Once you get 2 volts due to virtual short, right, V minus is equal to V plus is equal to 2 volts. Then I can calculate this voltage. So let me take this as V2 and this as V1. How to find V2? Already we did this kind of problem earlier also. So let me take this is node A. KCL at node A. V2 minus 2 by 20k plus V2 minus 0 by 20k plus V2 minus it is 2 by 10k is equal to 0. So kilo cancel. V2 by 20, V2 by 20, it is V2 by 10, V2 by 10 plus V2 by 10, V2 by 5. So V2 by 5 is equal to 2 by 20 minus 2 by 10. Okay. So how much do we get? It is minus 2 by 20. Minus 2 by 20 in the sense, okay, minus 1 by 10. Okay. Then V2 is equal to minus 1 by 2 volts. V2 we got. Once you know this voltage and this voltage, we know how to write the output, keeping these voltages in mind. If I know this voltage and this voltage, then I can write the output. V output is equal to, okay, minus 40k by 10k into V2 plus 1 plus 40k by 10k into V plus minus 4 into V2. What is V2? Minus 1 by 2. So plus it is 5 into V plus or V minus, it is equal to 2. Oh, sorry. Here we should add this 2. 2 by 20 plus 2 by 10. Sorry. So it is 5 by, sorry, 6 by 20. 6 by 20 means 3 by 10. What am I? So it is a plus 1.5 volt. 3 by 2. V2. So the final answer is 4 volts. Option D is correct. Anyway, simple calculations errors. Sorry. We can do it like this. 4 volts is the answer for this problem. Okay, assume that the op amp in the circuit shown is ideal. V output is given by. What is the output of this particular circuit? So very simple. Anyway, this is like load resistor. I need not worry about this. Due to virtual short, this is equal to V2 only. Okay. Then just by taking this node equation, we can get the output voltage. That's it. Okay. If this 2R is not present, then directly I might have written V output is minus 3R by R into V1 plus 1 plus 3R by R into V2. I might have written. But this 2R is present. So I can't take that. Okay. So apply KCL at node A. It is V2 minus V1 by R plus V2 minus V output by 3R plus V2 minus 0 by 2R is equal to 0. Okay. So V2 by R plus V2 by, anyway, R I can cancel. So V2 plus V2 by, or V2 into 1 plus 1 by 3 plus 1 by 2 minus V1 is equal to V output by 3. So V2 into here LCM 6, 6 plus 2 plus 3 minus V1. So is equal to V output. So what is V output? It is 11 by 2 into V2 minus 3 into V1. So minus 3V1 plus 11 by 2 V2. That's it. There is no difficulty at all. Because of this 2R, we should be careful. Okay, you cannot simply take the things like what I have mentioned. Okay. And adder subtractor circuit, a circuit which performs both addition and subtraction. Okay. See here, let me take first, it is V plus. Then let me take it as node A. KCL at node A. It is V plus minus V1 by R plus V plus minus V2 by R plus V plus minus 0 by R is equal to 0. R cancel. So V plus is equal to V1 plus V2 by 3. Once you know the voltage at this point, next due to virtual short, V minus is equal to V plus. Let me take this as node B. Okay, KCL at node B. It is V plus or V minus, anything we can write it, or V minus minus V3 by R plus V minus minus V4 by R plus V minus minus V output by R is equal to 0. Then anyway R we can eliminate. So 3V minus minus of V3 plus V4 is equal to V output. What is V minus, friends? It is V1 plus V2 by 3 minus of V3 plus V4 is equal to V output. So 3 and 3 cancel. So I can write V output is equal to V1 plus V2 minus of V3 plus V4. So addition in between subtraction. That's why the name adder subtractor. Okay. Here I gave two inputs to the inverting terminal and two inputs to the non-inverting and two inputs to the inverting. We can give 3 and 3. And here I need not change the resistor. We can take all equal resistors. With respect to inverting terminal, we can see 1, 2, 3 resistors, and with respect to non-inverting terminal also 1, 2, 3 resistors. Okay, 3 inputs. Just for your understanding sake, I am writing, right? But nothing to worry about it. The procedure remains the same. You can have n number of inputs: V1, V2, V3, R, 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 and R. That's it. V4, V5, and V6. The students can try this. I'm directly writing V plus, you get it like V1 plus V2 plus V3 by 4 resistors. So 4, that is equal to V1. Then final answer is like V1 plus V2 plus V3 minus of V4 plus V5 plus V6. Straight away I'm writing. It's not like a non-inverting adder. In non-inverting adder, we kept on changing the value of feedback resistor. Here, you need not. That is the difference. If they give different resistor values, the procedure remains the same. Okay. See this question. For the circuit shown below, taking the op-amp as ideal, the output voltage in terms of its inputs V1, V2 and V3 is. Okay. So it is V plus and V minus, which is of course equal to V plus. So KCL at node A. V plus minus V1 by 1 plus V plus minus V2 by 4 is equal to 0. So what is V plus from this? It is V1 plus V2 by 2. Sorry, V1 plus V2 by 4. Let it be, depends upon V1 plus V1 by, sorry. Okay. Here V plus V plus by 4, that is 5V plus by 4 is equal to V1 plus V2 by 4. Okay. So what is V plus? It is equal to 4 by 5 V plus V1 plus 5 V2. V plus. Then once I know this voltage and this voltage, the output is given by V output is equal to minus 9 by 1 into V3 plus 1 plus 9 by 1 into V minus. V plus is equal to V minus. It is minus 9 into V3 plus 10 into 4 by 5 V1 plus 5 V2. V2 by 5, not 5 V2. Today I did mistakes. Okay, so finally what we can write here, it is 8V1 plus 2V2 minus 9V3. So option D is correct. Okay. So this in the circuit shown, V output is equal to VOA for switch SW is in position A and VO is equal to VOB for switch in position B. Assume that the op-amp is ideal. The value of VOA by VOB is. Okay, switch is initially at position A. Okay, position A means case 1 I am writing. One volt, 1K, 1 kilo ohm. It is position B, 1K and 5 volt. it is VOA. Like this a circuit, it is in air. So here no current is possible. And what about V plus? It is current voltage division rule. I can write V plus is equal to 1 by 2. And this is no way playing any role in the circuit. So I can write V output is equal to, here the voltage is 5 volts and here the voltage is 1 by 2. So I can write the overall output here is equal to minus 1k by 1k into 5, this resistor by this resistor into 5 volt. Next plus 1k by 1k into V plus or V minus, both are same. So it is minus 5 plus 2 into what is V plus? It is 1 by 2. So finally what we get? Minus 4 volts. VOA is equal to minus 4 volts. Similarly, connect the switch to B, position B. What is the output? Let us check that also. It is 5 volt and it is 1 volt. Okay, here this is 1k, they do not play any role, we need not worry about it. So now it is like simple adder circuit only, we studied this, all the resistors are equal. Okay, so what is the output? It is minus 1k by 1k, anyway equal, directly I can write minus of 5 plus 1, inverting adder circuit, minus 6 volts. Previous one minus 4 volts, it's minus 6. VOA by VOB, minus 4 by minus 6, that is 2 by 3. That's it. I think options are not given, directly we can take the answer. Yes. Look at this question. An ideal op-amp has voltage sources V1, V3, V5, etc. odd number connected to the non-inverting input. Okay. And V2, V4, V6, etc. Vn are connected to the inverting input. Fine. Okay. The voltages V1, V2, V3, V4, V5, V6, etc. are 1, minus 1 by 2, 1 by 3, minus 1 by 4 alternatively, plus 1 by 5, minus 1 by 6, etc. The output of the circuit. Simple ladder subtractor circuit only. Right. What I said, all equal values I took. Instead of all equal values, inverted, the resistors connected to the inverting terminal are 10k and resistors connected to the non-inverting terminal are 1 kilo. Okay. Then what is the overall output? Let me take it is V plus. Don't apply any kind of superposition here, that kills the time like anything. Nodal analysis. If you have only 2 inputs, then you can think of superposition, but not required here. Waste of time. So node A, KCL at node A. It is V plus minus V1 by 1k plus V plus minus V3 by 1k, so on, plus V plus minus Vn minus 1 by 1k plus V plus minus 0 by 1 kilo ohm is equal to 0. So now I can cancel 1k in the denominator. Total how many? Okay, These are n by 2. I can write, and it is 1. So further I can write it like V plus divided by, V plus into n by 2 plus 1 into V plus is equal to V1 plus V3 plus so on plus Vn minus 1. So that V plus is equal to V1 plus V3 plus so on plus Vn minus 1 by n by 2 plus 1. Keep it aside. The same thing we can take at the non-inverting terminal as well. V minus. V minus is equal to V plus. So V minus minus V2 by 10k. Same story I am writing. KCL at node B. Let me take it as node B. Then V minus minus V2 by 10k plus V minus minus V4 by 10k plus so on plus V minus minus Vn by 10k plus V minus minus V output by 10k is equal to 0. So I can cancel all 10k's. Further, V minus into, here also they are n by 2 plus 1. These are all n by 2. And it is 1 is equal to V2 plus V4 plus so on plus Vn plus V output. Or I will do one thing. Here you take minus is equal to output. That's much better. And what is V minus? V minus is equal to V plus is equal to V1 plus V3 plus so on plus Vn minus 1 by n by 2 plus 1 multiplied with n by 2 plus 1 minus of V2 plus V4 plus so on plus Vn. That is our output. N by 2 plus 1, n by 2 plus 1 cancel. So what is V output then? V1 minus V2 plus V3 minus V4 so on, plus Vn minus 1 minus Vn. And what about this V1? It is 1. It's minus 1 by 2. Minus of minus plus 1 by 2 plus 1 by 3 minus of minus 1 by 4 plus 1 by 4 so on. This is output equation. Okay. So an ideal op-amp has voltage sources connected to the non-inverting and inverting terminals as shown in figure. The value of V output. Here n is not mentioned. Okay. Actually question something is missing. If n tends to infinity, something like that. So if you observe this particular case, right, infinity terms. Then what is the sum of all these infinity terms? It looks like output is infinity. Is it possible? Not possible. If n tends to infinity. Okay. Then what is V output? Because it is less than V output maximum. Then what is V output? V output maximum. That is known as V saturation. In this example, it is 15 volts. That's it. Actually, something is missing in the data. That n is tending towards infinity. Something should be there. Right here, that is missing. Yes, look at this question. T networks. We observed the op-amp circuit with T network in the feedback path with input at the inverting or non-inverting. Here it is given to both inverting and non-inverting terminals. So it is something like not exactly differential amplifier, right? Something similar to that. Okay. So how do we do this problem? First of all, is there any current possible here? No. Whatever the current comes from 1 volt, entire current will flow through this resistor and this resistor. So let me take this voltage. As this is 0, it is V plus. As no current is possible here, this is also V plus. So V plus voltage division rule 1 into R by R plus R, it is 1 by 2. And due to virtual short, it is also V minus is equal to V plus is equal to 1 by 2. Okay, then let me take this voltage as VA and this as node A. So this voltage is known, this voltage is also known, then unknown is this voltage. By taking this node equation, we can find that unknown voltage. So KCL at node A. VA minus 2 by R plus VA minus 0 by R plus VA minus V minus by R is equal to 0. So R is cancelled. Then VA, we want it is 3 VA is equal to 2 minus V minus. What is V minus, friends? It is 2 minus 1 by 2. It is 3 by 2. Okay. Sorry, it is a plus. So it is 5 by 2. So VA is equal to 5 by 6 volts. Absolutely, in the node, the unknown voltage is VA we have got. Right. Next procedure, same. So we know this voltage and this voltage. By applying node equation, here we can find the voltage at this point. Let me take it as VC. We can find VC. Okay. So KCL at node B. It is VB minus VA by R plus VB minus VC by R is equal to 0. R cancel. So VC is equal to 2VB minus VA. 2 into VB. VB or right here. Okay, V minus. Let me write instead of VB. Okay. If I give more notations, students will be in confusion. Instead of VB, I write V minus. To V minus minus VA. So what is V minus? Voltage at the inverting terminal or non-inverting terminal? It is 1 by 2. And VA is equal to 5 by 6. So how much do you get? It is 1 by 6 volts. VC we got. Next. Here V minus is known and VC is also known. By taking the node equation here, we can find voltage at the next point. Okay. So KCL at node C. Okay, here I am writing. It is VC minus V minus by R plus VC minus 0 by R plus VC minus V output by R is equal to 0. So V output is equal to 3 VC minus V minus 3 into what is VC? It is 1 by 6 minus V minus is equal to 1 by 2. So the final answer is 0. That's it. Okay, the procedure remains the same. The procedure does not change. Once you are good in networks, just like that, you can study op amps. Okay. And the next topic is op amp with common input. We'll discuss it in the next class.